Okay, here's the graph of x to the 1/3 on this interval. So let's look for absolute max. There is none because there's an open circle there, can't reach anything. Is there an absolute minimum? Yes, there is. So f of -1 is -1. Is there a local max or a local min? Local max would mean a peak. Nope, none. Is there a local min where there's a valley? None. Okay. How about 1/3 x? So it includes both of the endpoints. So absolute max would be f of 2, which would be 2/3, right? And then absolute min would be f of 0, which would be 0. Are there any local max or local min? None. Either of these, because there's no valley or peak. All right, one more. Cosine of x between 0 and pi. So is there an absolute max? No, there is not. It doesn't reach this endpoint. Is there an absolute min? Yes, f of pi, which is -1. Is there a local max or a local min? There is not either of these because there's no peaks or valleys. All right, so let's look at critical numbers. So first off, this number c has to be in the domain of the function, and it's got to make either one of these true. So let's go find the derivative. So I have 3x squared plus 2. So if I try setting it equal to 0, there's no solution, right? So there's none of those kind of critical numbers. Is there a place where the derivative doesn't exist on this function? Nope. So there's no solution. So there's no critical numbers on this function. All right, let's try this one. Take the derivative, I get 1 minus 1 over x. Okay, let's find the critical numbers where it equals 0. So it looks like 1x equals 1. Okay, is this in the domain of the function? Can I use this in here? Yes, I can. So that's a good critical number. So that's where the derivative equals 0. Okay, let's check out the derivative does not exist. So that means I want to look at this function. Is there an x value that makes it not exist? Yes, x equals 0. But is this in the domain of the original function? Can I use x equals 0 inside of ln? No. So that doesn't exist. So this is the only critical number. Do we know how to do a derivative of absolute value? We do not, but you know the graph looks like this. So is there a place where the slope is 0? Derivative equals 0? No, there's no slope 0. So there's no h prime of x equals 0. There's none of those. How about where the derivative doesn't exist? Where would that be? You know, a corner the derivative doesn't exist. So x equal 2 is the only critical number. All right, let's take the derivative here. So I get theta is like an x, so I get 1 minus secant squared of theta. So I set it equal to 0. So I have secant squared theta equals 1. So that you know that's 1 over cosine squared. But if I take the square root, I get secant of theta is plus or minus 1. So when does that happen between 0 and 2 pi? So you know that's 1 over cosine of theta is plus or minus 1. Cosine of theta is plus or minus 1. So that means theta is pi or 0 or 2 pi. All of those give me the derivative equals 0. Is there any place that the derivative doesn't exist? Nope. All right, so let's try this one. So we have to always start with the derivative. So I get cosine of x plus sine of x. So I set that equal to 0. And you're thinking, yep, I want to put 1 on the other side. So I get negative cosine of x plus sine of x. Oops, I'm sorry. I meant equal sine of x, right? So where are the sine and the cosine the same number except differing by a negative? So you're thinking here and here, right? And it says for all reals. So I'm going to take advantage of x equal, so that's 3 pi over 4 plus k pi. So those are all the places where the derivative equals 0, and there's no place where the derivative doesn't exist. All right, one more. So let's take the derivative here. So I have 2 cosine of x times negative sine of x, doing the chain rule, minus 2 cosine of x. All right, so I want to, I'm just going to erase this for a second here. So I want to set this equal to 0, so you know you want to factor out the common terms, which would be 2 cosine. So I get negative sine of x plus 1 equals 0. And so that means I'm going to set cosine of x equal to 0. And I'm going to set negative sine of x plus 1 equal to 0. So that'll give me sine of x equal 1. So it just says between 0 and 2 pi. So this will give me pi over 2 and 3 pi over 2, right? And then this here gives me x is equal to pi over 2. And I will do this when we return.